Hello everybody, welcome back to Young Tutored. So today we will be taking up the topic of real numbers. So what is this real number? What do we consider real numbers to be called? So if you first for understanding real numbers we need to understand the topic of rational numbers, because rational numbers subdivide even more to get real numbers. But there are two topics in total that form this real numbers, because right now we've covered almost every single point on the number line, because it's easier to take as a number to take the number line as a representation of the numbers that we are using here. So we usually use the number line as a marker to tell what all numbers have we covered. So for example, let's take a number line and imagine a number line in our head. So if we mark all the numbers, all the positive natural numbers, that is all the natural numbers, if we mark, we add a 0, we get a whole numbers, we get the whole numbers, we add the negative section of it, we get the integers, and then we add all the rational numbers, that is all the fractions, negative fractions, and we get the rational numbers. So till now we've been only working with rational numbers, and most of the time we've never ever looked at the side of can there be more numbers on the number line, because we've defined. So let's see what is the inverse, or what do we consider as the second topic. So first topic, we are sure that rational numbers is one of the topics that come under real numbers. So if you take real numbers as a subheading, then we can subdivide this into two: rational numbers and the second topic, we'll come back to that later, because I will tell you as I go on. So we know what are rational numbers. We've covered them thoroughly in another video. If you want to check that out after this video, or right now and then come back to this video. But what do we consider to be the second part? So let's imagine the root of a number, because usually we never work with square roots on a number line. So let's imagine pointing a root of a number on the number line. We can easily mark roots like root 4 and all the other square numbers and the cube numbers and everything else. But how can we mark a number like root 2 on the number line? We don't know the exact value of 2. We don't know exactly what can we give, or where does it exactly lie. We cannot give an exact location for it visually. And plus, these numbers cannot be written in the form of rational numbers. For example, let's take an easier example in this case. Let's see the number, well-known number, pi. We consider pi to not be a rational number because it does not have a repeating decimal. In the last video I told you what are decimals. They're repeating decimals, non-terminating, terminating decimals. So if you watched that video, just recall that for a second. I'll give you a second. Okay, so now that we've kind of remembered what are the decimal endings are, we know that there's a last fourth type of decimal ending. I'll just tell all the four right now. The first one is terminating, where the decimal actually ends at one point of time. Then there is non-terminating, recurring, that means it recurs for a certain amount of time. And then there's the third one. I didn't mean fourth, I mean the third one, which rational numbers do not come under, which is non-terminating, non-recurring. That means they don't reoccur, or these decimals don't repeat at one point of time. They keep on going with random numbers coming in between, and there's no sign of it to repeat from one number to another. And that's why we consider pi as an example. We just use 22/7 as an approximation of pi instead of telling that number is equal to pi. Okay, so now that we know what we've understood that the second topic of this is very related to decimals, and therefore we can link to decimals to this number. We can link decimals to this number. Let's try to imagine what could be the opposite of this word rational. Let's take regular, for example. We have irregular. So in this case, it is irrational numbers. what are these irrational numbers? These irrational numbers are the kind of numbers which don't have a particular value that we can denote them. We can give them an approximation, but we can never find out the exact value of these irrational numbers. So of course, rational numbers, when they're combined with irrational numbers, form the real numbers. Now of course, real numbers do expand to even more complex topic, but for this time, let's just stay under the real numbers chapter. So now we can, using irrational numbers and rational numbers, with the combination of both of these numbers, we can finally mark every single point on the number line. But some of you might be asking, how can we mark, for example, an irrational number or a root of a number on the number line exactly by like trying to find the most approximate point of it on the number line without using visual guesses? If one of you had a question like that, then there is a very simple answer to it. By the way, you will require complex like some simple materials like compasses and protractors to make this possible, but I will give you a brief or like an understanding of how to do it, but you must use an exact protractor to get the exact value. So let's take this as a number line. Maybe not straight, but okay, my drawing handwriting is bad. Let's take this as a number line. If this is our number line, then let's stick in the positive side only, because the negative side gets very complicated. So if we start with 0, we'll go up to 1, 2, 3, 4, 5, 6, 7. Okay, so how do you mark, let's take the number root 2. How do you mark root 2 on the number line? So the simplest way to do it is by taking, so remember that all of this should be evenly spaced out. So the best way I'd like to do is taking up 1 centimeter of each of these that is already present on your scale and just marking it that way, because that is very accurate. So let's take this as 1 unit. Then we have to go 1 unit upwards. So let me just move that. And let's take this is equal to 1 unit. This is equal to 1 unit. And remember that this must be exactly perpendicular to this line, number line. That means it should be straight up in the air. That's the reason I prefer using a protractor in this situation. Then take this end and connect it to the zero, to the start. That is from where you took the first unit. Remember that you must usually, as long as there's no addition, subtraction, division or multiplication done on this, you have to always start from 0 to find the exact value of it, including the whole number part, or else you'll only get the decimal parts correct. So if we apply the Pythagoras theorem in this case, which is, let's take this is the Pythagoras theorem. If this is equal to a and this is equal to b, then 1 square plus 1 square is equal to, well, c square, because we don't know the value yet. That is, c is in this line. So this will further continue to 1 plus 1 equal to c square. So c square is equal to 2. And now, because we need to find the value of c and not c square, we just take the square to that side and inverse it. That is, inversing means putting a root on it. So it becomes c equal to root 2. Meaning, using the Pythagoras theorem, this is equal to root 2. So now we got this line, and we know that this distance is equal to around about root 2. If this is equal to root 2 but it's not on the number line, we need to mark it on the number line. So let's take, for example, take a compass, put a pencil, and join these 2 points and bring it down to where it intersects with the number line. Now wherever it intersects, put a point, and that point is the exact distance of root 2. But remember, you must like draw a line between here like that. So that's pretty much how to mark root 2. But what if you want to go bigger? Root 3, let's take. Then you have to, as we have taken 90 degrees from this, you have to take 90 degrees from this. And remember that no matter what you're trying to do to mark just a root number, you have to always take one unit on this side, whatever unit you're taking. So it must be perpendicular to this line at the very edge of it. And then join these two lines with your base being one. If let's take you want to find root n, and as long as n is not a square number or n is not my bad, root of this number is not a whole number, we can't directly mark it on the number line. So what we have to do is always have the base equal to n minus 1, that is this line equal to n minus 1, and you have to keep on applying this formula until the new number, that is whatever number we get, is equal to is a perfect square number, that is we can mark it on the number line. So for example, if you want to mark root 5, we can directly take 2 instead of doing the entire spiral. Okay, so we've understood how to mark rational numbers on a number line. But how can we apply operations on these numbers? That is, how can we add, subtract, multiply, or divide with these numbers? So let's take a certain situation, because we are working with real numbers here, and real numbers we know are rational and irrational both. So if you are working with real numbers instead of just irrational numbers, then we can take it in such a way. If let's take addition. In the case of addition for real numbers, let's take one scenario. We are adding 3 and root 2, that is 3 plus root 2. Now we can see here that we are only adding a whole number to this number, which means we are just giving it the whole number changes but the decimal section doesn't change, meaning it's still non-terminating, non-recurring. Therefore this is also along with root 2 irrational. Okay, now let's take a second scenario where we are working with only irrational numbers. So if you are working with only irrational numbers, there is a chance for both. It can be either rational or irrational. So how can it be rational, for some of you may ask? We can prove that addition between two irrational numbers can be rational by just saying root 3 plus, by adding both of these we get an irrational, which I will prove later on. It's 2 root 3, which means this proves that these two numbers add up to an irrational number. But how can addition bring an rational number, you might ask? Okay, so to add two irrationals, which gives a rational answer, the best example would be by taking minus root 5 plus root 5. So in this case, we are adding minus of root 5. That is because we don't know what is minus root 5. So we are doing minus of root 5 plus root 5. In this case, when we add both of these, we get the answer 0. So this is practically the three ways in which we can use to prove the addition of real numbers. So addition of real numbers can be either irrational in two ways, or rational in exactly only one way. Now let's see the subtraction of these real numbers. How does subtraction of real numbers actually work? So let's take the subtraction. For subtraction, again, there are the same three outcomes. If there is there's a rational number and irrational number that are being subtracted from each other, then it will always end up being an irrational number. For example, if we take 1 minus root 2, this is equal to an irrational number. But now let's see if two irrational numbers can equal an irrational number. If we take root 3 minus root 2, this is also irrational. And if we take root 7 minus root 7, this is 0, which is, we all know it's rational. So again, in the same way as earlier, there are two possibilities of a real number having irrational as an answer as irrational, but only one way it can have as a rational number. Now let's take the idea of multiplication. So let's see how do we multiply two real numbers to give and what do they give. So let's take, for example, root 3 that's being multiplied with root 2. So you should always remember, so I'm doing over here the two irrationals that are being multiplied by each other. So you should always remember that whenever two irrationals have a multiplication sign between them, we should always make them act as variables, like how we tell 3a or 11abc or something like that. We give whenever there's an unknown value to a number, we just join them with its coefficient. The same way we can do it with these numbers. And whenever two numbers like this is being multiplied by another, two irrationals which have a root, we can directly write root 3 into 2. And we can further simplify this as root 6. So now that we know what root 6 is, now that we know that this is one way of multiplication, let's see another way of multiplication. Let's take 3 into root 2. Let's take 3 into root 2. So 3 into root 2 is equal to 3 root 2. We cannot simplify this even more because this is an irrational number. So we've seen two ways of how these real numbers can be irrational. What is one way of them being able to be rational, you might ask? Well, in this case, there are two ways of them being rational. One way is for them to be multiplied by 0, which is a rational number, and as any number multiplied by 0 is 0, this is rational. Another method of these being able to be well equal to a rational number is, actually wait, this is the only way they can actually be rational. They can be rational numbers. There is no other method as I know which can make these real numbers rational during multiplication. The same applies for division. The same way applies for division. The same, whatever multiplication, just replace it with division. It will be the same as we know it. Apart from dividing by 0, in division it will be just 0 divided by root 3, for example, or any root number. Okay, so I want you to remember one key point, that is, for any prime number, if we take a root of that prime number, we will always get an irrational number. So if you want to, for example, give an example of an irrational number, you should know that that number's root that number must be a prime number, because its root will always be irrational. So it's a very key point to know. Okay, so now let's continue with our homework session. So I have given a simple homework today, which is to tell if a number is either rational or irrational. For the first example, let's take 1 by 3. For the second example, we can take 2 root 7. For the third example, or third question, let's take root 8. For the fourth example, I'll take root 25. So remember, some questions might not be simplified to their base, but they can be either rational or irrational. Now I'll be giving a total of 8 questions. These are 4. This fifth question is, cube root of 21/6 or 216. Cube root, by the way, if you don't know what's cube root, you have to just take the cube root. I've explained it in another video a long time ago, so you can watch that video to understand how to take a cube or a cube root of a number. Then root 35, then we'll take a very simple one, 7 minus 4 root 21. So you must think a lot for some of these questions, but in the end they're very simple. They don't require much calculation, because I'm not asking you to find their roots or something. I'm just saying that you must know what are they, whether they are irrational, rational, or if they are just neither. And for the last one to be very simple, very easy, let's take 1 plus root 11. So think well, think a lot, try to figure out their answers. If you do get it, then if you know all of their answers, then comment down below. The comment box is free for all of you. You don't need to be shy or anything to get to know what is the answer. Just if you don't know any one of these questions answered, then you can ask in the comments below. I will reply to you also. Thank you for watching, and this is Young Tutor. Subscribe to the channel if you've not already subscribed, and also like the video. If you've really liked the content, then you may also go ahead and share it to your friends or family so that they can also learn about real numbers or just any other topic on this channel. Thank you.